So let's stop debugging session right here, and as soon as we're done with the debugging and we're satisfied seeing the result, the debug breakpoint can be removed from the program. So we have another example on this slide that is demonstrating another function where we have an example of reference syntax, and I'll just like copy and paste this into our source file right here at the top of our file. And I'll just enlarge the font here. So we have two integers named x and y, and we initialize them to certain values. So this is integer x right here, and this is integer y, and both are local integers inside this function f. Okay, so then we declare a reference to an integer named ri, and we initialize this reference with the name of the object I, which is an integer. So now both I and ri become names for this integer. So if, for instance, now we use ++ri, we're now incrementing this object because this name refers to this integer, and of course now I becomes 5, so it gets incremented. If we say ri equals x, which is integer 8, now we're simply, again, through this second name of I, which is a reference to I, again, we're just updating I, and now if we're saying take this value and store it here, of course it gets updated, and now I becomes 8. So both of these integers become 8 right here. And an attempt to create a reference to an integer and sort of like point it to a literal value is an error. The right-hand side, right here, of the initialization for a reference must be an L value. L value means left value, and it means that some kind of value that can be used on the left-hand side of the assignment statement. Of course, 2 cannot be used on the left-hand side of the assignment statement. However, something like this or like this or like this, of course, can be used on the left-hand side of the assignment operator. And so they all can be used to initialize this second reference in this little example, but not a hard-coded integer value. So this is not acceptable way to initialize a reference. Now, once references are created, like we've shown here, they themselves cannot be changed, right? So here, for instance, if we have these three things, I, X, and R, which is a reference initialized with I, then if we use this reference, it can never change to point to anything else. And this feature that once initialized, a reference cannot be changed to point to anything else. It gets, like, for its existence, it gets stuck with just being the second name for some other objects that was used to initialize it. So in this case, or rather, this idea that for the existence of a reference, it cannot be changed. This really what makes it possible to use these references as if they were original variables. So there's never a second thought about like where this left and where this right are pointing to. What are they giving us access to? As you could see in debugging session, left and right were just simply displayed as if they were the original integers 1 and 2 with values 1 and 2. So they're basically stuck with the values that were originally provided to this function when the function was invoked. Okay, so these are examples of like attempts to experiment if the reference itself can be modified to point to something else. And so you can just like take every single line here and experiment in your own compiler window and see what is the behavior of these lines of code and what can you observe perhaps in a debugging session, or you can even add some code to display all of these values on your screen to just be confident about the behavior of each single line like this. Just remember, the bottom line is that a reference is a second name for an existing object to begin with. Yes, there are some differences. There are some situations where you can actually distinguish references from integers in areas where you can use generic programming and C++ templates, but in the plain example like this, a reference is just a second name for an integer. Now, there's this interesting thing to know about references, is that when you have a class, and inside class, unlike structure that we used to demonstrate structure rectangle in our previous series of examples, in a class, if you have two private integers, basically integers that are visible only inside this class, it's possible to add a function which returns a reference to an integer, and this way, through this reference, you can basically expose access to a private member inside your class. So this is a technique that sometimes is referred to as a trapdoor or backdoor, and so it allows the data to be modified outside of the class regardless whether the actual data is private or public. So it's just a general knowledge of the possibility like this to exist. But right now this is just for your information, and this is not really critical or important to the examples of the code that we're going to be using in the near future.